In this lesson I will discuss how to use variables. This time we deep dive into the usage of variables in bash session and more precisely using them within bash profile and bashrc. I am now in the home directory of a user. The ls allows to display all the files created here by a user, but this catalog contains much more files and we can see them executing ls-a. The additional files which have been displayed now start with a dot. On Unix, when a file name begins with a dot, then it is considered as hidden and normally such files are not shown to the user. Well, maybe a normal user indeed will not be aware of the hidden files, but if a user heard about option -a, there is nothing what could stop him from displaying the files. Okay, so now we can see here among other files a file named bash profile and bashrc. Let's look into content of the files. Bash profile is a script executed each time when you start a new session. When you connect to Linux and this nice black terminal window is displayed, at this moment the script .bash profile is executed. Even a moment earlier, another file named profile from directory etc is started as well. The etc profile is common to all users, but the .bash profile can be modified by the user, by the owner of that directory. The file bashrc is also started when you open a new session to Linux, but it is also started whenever you start a new shell. Yes, a shell can be started without establishing a new connection. You can just execute bash command and then a new shell is started and bashrc is executed. In a moment we will test how it works, but currently come back to the bash profile file. Well, the lesson explaining the conditional statement is still before us, but this line here takes decision. If in the home directory of the current user the file .bashrc is present, then it should be executed. After that, we have still empty section encouraging user to add here his own variable definitions or calls to external programs. Okay, so let's check the content of the bashrc file. Here there is also an if statement. If the file etc bashrc exists, it would be executed. Next, some environmental variables should be changed. The variable path contains a list of catalogs that will be searched when a user executes a command. Here, to this variable we add .localbin and bin. The syntax may look a bit strange, but apart from the new directories, we append here the current value of the path variable. We can easily check the current value in the path. Echo $path shows that at the beginning of the variable we have the already mentioned .localbin and bin. The rest of the directories are system directories. This is a small hint for us as the scripters. Every user can save his script in one of the discussed here directories, and when executing the scripts, he or she will not need to point to the script file using relative or absolute path. The typed by the user command will be searched and hopefully found in one of those two directories. At the end of the bashrc file, again there is a place to add user variables. To better understand those two files, let's add variable definitions in the both files. Let's start with bash profile. At the end, I'm adding a variable. To avoid confusion, the name and value of the variable shows where it was defined. Profile var. This variable was defined in profile. To note the execution of the file, also a message will be shown. Hello, that's me, your bash profile. I will do similar change in the bashrc file. The variable name is now bashrc var, so the name points to the file where it was defined. I'm also adding an extra message displayed when the file is executed. Let's see what will happen when I log on again. Okay, I can see the messages. The first one is from bashrc and the second from bash profile. Next, I can check the values of the variables. The both should be available. You may think that's quite normal. We have defined them, so they need to be present. Easy. So take a look at the next activity I will do. I will start once again bash. Look, now only one message is displayed. This one from the bashrc file. Indeed, I told that when a new shell is started, then the bashrc is executed and the bash profile not. So no wonder that the variable bashrc var is present. But have we also the profile var? Unfortunately not. But why? The reason is that the variable is created only when a new session is established, so it's present in the first bash that was then started. When in this first bash I started another process, here the second bash, then the new process is unaware of the variables defined within the first bash, first process. Maybe not intuitive, but logical. This default behavior can be changed so that a variable defined somewhere once will be visible in all child processes as well. How to do it? Look, I will open the bash profile again. To make a variable visible to child processes, the variable should be exported. It is enough to write line export profile var. This could be even done in one line, just export profile var equals value. To test how it works, I need to open a new connection again. The messages visible on the screen show which scripts were started. The variable profile var is present. The variable bashrc var is also visible. So there is no difference to previously discussed situation. Now I will run a new child process, here another bash. The message is generated by bashrc script, so the variable bashrc should be defined. It is. Good. And now the most important part. Is the variable profile var visible? The variable is available, and that's despite the fact that the bash profile was not executed. The variable was designated as exported, and now the child processes will see it. Such sharing of variables work only in one direction. The child processes could change the variable's value. The new value is indeed applied, good, but when the child process would be ended, and in the parent process I will try to display the variable value, the old value will be presented. Each shell has its own set of variables, session environmental variables. Different sessions, even in case of parent-child relation, don't exchange with them. Why have we spent so much time discussing environmental settings while the course is dedicated to programming of custom scripts? Well, it seems that we can just copy and paste some ideas from clever developers of operating system. When you develop your script, you may have idea of splitting your solution into multiple parts, files. One of them will be responsible for the actual work, copying files, creating directories, changing system settings, and so on. The other part can be used just to define the most important variables. Let's demonstrate such attempt. I am creating a new file named config.sh. Here, I will define a few variables. Let's imagine we develop script installing financial booking application. The variable install_dir says the installation should be done in the following directory. Compress level sets the level of compression of the data. Timeout defines that the application should wait 30 seconds for a file transfer to be finished. Just some fictional settings of a fictional application that surprisingly could be met in a real application. I think it's a good idea to mark those variables with the export statement. All the child processes started from the initial process will also know the values of the defined here variables. Now it's time to create the second part of the script. Here indeed some actions should happen. This is a bin bash script. The very first instruction will cause that all the content of the config file will be read into the current script. For this I will use the command source. Source causes that the config script is executed within the current process. That's important. Without the source word, the script config would be started in a new bash process. It would load into memory, define the variables, and after that it would finish and all the variables would be removed from memory and forgotten. Source will execute the config script in the current process that is still not ending, so the next command can use the variables defined here. So now in the following instruction I can use the variables defined in the other file. Clever! Here I will just display the variables: install dir, compress level, and timeout. It's time for a test. I will add execute permission to the setup file, but I will not change permissions on the config file. It will remain as is, just a text file. When I start the setup as H file, the non-executable file config will be executed, and the contained here variables will be read and left for use for the setup script. If you are interested, the word source can be replaced with a dot. Well, that's quite strange entry. Dot space dot slash config.sh. The first dot is only a shortcut replacement for the word source. Up to you what you will use. Modification is saved, so let's see if the script still works. All seems to be okay. Good. What have we learned in this lesson? We have seen how the script bash profile and bashrc are working. We know that variables that should be visible for child processes should be exported. Next, we have applied all this knowledge to build our own script. Our script should perform some actions basing on values of variables that were defined in another file. Additional value of such solution is that if an admin should modify the settings of the script, he or she would need to change values only in the config file. This activity would be similar just to changing some settings in the config file, not a pure script. That is one of the tricks when programming in shell. In the coming lesson I will show how to perform calculations in bash.